Hey guys, today we're working on 6.2, proving trig functions. Alright, so I wrote down some helpful hints that I think might help assist you in doing these problems. And good news, we're really not doing anything different than what we've been doing the past 2 days. They're just going to get a little bit more, a little bit longer. So this is good practice, and it'll help you do better with 6.1. Okay, so helpful hints. Do anything algebraic, i.e., if there's two terms and you only need one, like I've been telling y'all, you want to add fractions, okay? Get the right denominator, or factor something out. The next one is multiply by a clever form of 1. And you're probably like, what does that mean? Like multiplying by its conjugate is one example. So if the problem was x plus 1, the conjugate of x plus 1 would be x minus 1. Okay, so you'd multiply the top and bottom by that. Okay, and then do anything obvious, like if there's distributing, do that. If you need to factor something out, you can do that. Remember, this is a trial and error type of a process, and the more you do, the better you get. Okay, the other thing is doing trigs, and you're just going to do substitutions. Okay, and then last but not least, always refer to the answer to keep in the right direction. Okay, always make sure that you kind of know where you're trying to go and try not to get too far off from that. Okay, last thing is you can only work on one side of the problem. You cannot do both sides of the problem. Okay, so let's go ahead and do some examples real quick. First one is secant squared of x minus sine squared times secant squared of x. Okay, so going back to our hints for our algebraic terms. Okay, we have two terms. The first one, and here's the second one, and we only need one term. Okay, we can add fractions. We don't have any fractions here. But what if we factor something out? If you notice, both of our terms have secant squared. So if we pull out secant squared of x and put parentheses here, you're left with 1 minus sine squared of x. Okay? Also, remember what I said, when you see sine squared and you see a 1, you're probably going to be using a version of Pythagorean identity. Okay? So if we were to solve for cosine squared, we would be left with sine squared of x. Okay? So this right here goes to cosine squared of x. Oops, secant. Okay? And secant times cosecant, if you don't know off the top of your head, goes to 1. But if you want to see it all out, you can totally write this out. You know secant is 1 over cosine, and so secant squared is also 1 over cosine squared. So basically, those all cancel. So we just proved this identity, or this function. Okay? And remember, if I go too fast, press pause. Okay? Let's do another one. So we got one, this is example 2. So we got 1 plus 2 tangent squared of x equals secant to the 4th power of x minus tangent to the 4th power of x. All right. We are going to pick one side. And another helpful hint, which I probably should have written up there, is start with the more complicated side. which I would think it's the right-hand side of this equation. So we're not going to mess with the left-hand side. Okay, this is going to bring you back to algebra right here. Okay, or algebra 2. Okay, these two numbers, secant to the fourth power and tangent to the fourth power, are a difference of two perfect squares. And I know that's going to ring a bell, but you know that a plus b, a minus b, you should know from your Algebra 2 or Algebra 1 teacher, that when you can factor a squared minus b squared to get a plus b times a minus b. Okay? But you're probably thinking, well, that's great. We don't have a squared. We have 4s. Well, 4 is still a perfect square. So this turns into a squared here, squared there, squared here, and squared there. Okay? So let's go ahead and do that with our problem. Okay, we're going to factor these out. So we got secant squared x plus, oh, and I wrote way too, or made my parentheses too small, plus tangent squared of x, and then secant squared of x minus tangent squared of x. Okay, we did nothing to this side. No, you do not need to write this side out every single time. I'm probably not going to do that anymore because we're not changing the left-hand side of the equation. Okay? All right, you're probably thinking that one or both of these probably have a version of Pythagorean theorem, which you're right. Okay, so again, I want y'all to have your formula chart out. So we got tangent squared plus 1 equals secant squared. Well, we don't see plus 1 anywhere. But if we solved for 1, we would get secant squared minus tangent squared. Right there. So we get to substitute 1 in place of that. So we still have secant squared of x plus tangent squared of x. Okay? See how that kind of nicely canceled out and already looks a little bit easier? Okay? Now, going back, because we still got to cancel this out, going back up to the original Pythagorean identity, secant squared, I'm going to plug in tangent squared of x in place of secant squared, which you're allowed to do. So tangent squared of x plus 1 plus tangent squared of x. I don't need to write the times 1 because that anything times 1 still gives you the answer. And guess what? We have our 1. Our answer has a 1. And how many tangent squareds do we have? We've got 2 tangents squared of x. Okay? Press pause if you needed some time to kind of think more about that and maybe work some more. Okay? And we're going to do one more problem, which is a conjugate type problem. So this will be good good practice before Monday. So we got cosecant minus cotangent of x equals sine of x all over 1 plus cosine of x. Whoa, that's not the next value. Okay? So, again, our more complicated side is the fraction. And I know you guys probably want to stay clear of the fraction, but guess what? It's harder, it's more complicated, so it's going to make it so much easier. So, I want you to put a little side note, so when I tell you to multiply by the conjugate, you can look back and see what we did here, okay? Because this is what we're going to do. The conjugate of our denominator is 1 minus cosine of x. And you also have to multiply the top by it. Okay? I want you to FOIL the bottom, but don't do anything to the top for me. Okay? We're going to leave it simplified like this. And you'll see why in a second. Okay, once we FOIL, we get 1 minus cosine of x. Cosine times 1 is positive cosine x, and then we're going to get minus cosine x squared. Cosines cancel. And we get sine x, 1 minus cosine x, all over 1 minus cosine squared of x. Hopefully you've kind of realized that that right there is part of the Pythagorean theorem, or not Pythagorean theorem, it's the Pythagorean identity. Okay, so cosine squared plus sine squared equals 1, but what we did was basically are going to solve for sine squared of x. So we have sine x times 1 minus cosine of x. Okay, basically we could we have 2 signs on the bottom, so that would cancel with that there. 1 minus cosine of x all over sine of x. Okay, let's look back up at our problem, what we're trying to get it to look like. Okay, we got cosine, I keep saying that wrong, cosecant minus cotangent. Well, we are almost done. 1 over cosec. Okay, it's Friday at 5 o'clock, so I'm getting a little delirious. 1 over sine of x minus cosine of x over sine of x. Okay, all we did here is we split up the fraction. So we put 1 over sine and then cosine over sine. Okay, because the reason why I would do that is 1 over sine equals cosecant of x, and cosine over sine is cotangent of x. And that is the way you solve this problem. Okay? Let me give y'all a little bonus problem. Okay, so your assignment is to solve this problem on a piece of paper and turn it in to me on Monday. Don't tell your classmates unless they actually watched the video, because that's not fair. And I will know if people watched it, because if I don't get 60 views, then I'm going to know. So what I want y'all to do is solve this problem right here. Okay, here's a hint. I want you guys to not combine like terms, or combine fractions. Make this into 1 over sine, and this one 1 over cosine. And that's the only hint I'm going to give y'all. Y'all have a great